Hi students, in this video we will be going over operations with decimals. Our essential question for this lesson is, how are the operations used to solve problems with decimals? So again, how are the operations used to solve problems with decimals? First, we're going to go over comparing decimals. To be able to understand comparing decimals, you're going to need to have a good understanding of the decimal place value chart. Now, if you want to copy this chart down, you can. However, it's also in the back of your interactive notebook on those math reference pages that we glued onto the very last page. So you can also view it there if you don't want to copy this down. But let's see if we can identify some of the numbers in certain place values. So we have this very large number here, and we want to figure out what number is in the hundreds place, what number is in the millions place, the hundredths place, and the tenths place. Now, it's very easy because we have this chart right here, and we can just look and say, oh, okay, in the hundreds place is the 8, okay? And in the millions place, just the millions, not the 10 millions or the 100 millions, but just millions, is the 4. The one thing, though, that students often get confused on is the difference between hundreds and hundredths. Hundreds is our whole number, okay? Whereas hundredths is talking about our decimal point, which is over here, and that would be 5. So the hundredths place is a decimal, and you can always tell if it's going to be a decimal place value based upon if it has that THS at the very end. So in the same way, you can see the tenths, that has THS at the end, which means it's going to be in the decimal place. And that number then is 3. So identifying the decimal place values is very important. And when you look at a place value system, the largest number and place value is on the left side, and the smallest is all the way over to the right. So even though thousands sounds like it'd be bigger than tenths, it's actually quite smaller than the tenths place. All right, let's compare some decimals with what we've been learning. So here are a few sample problems that we're going to look at. And we want to say which one is bigger or less or equal. So when we look at each problem, start on the very left to see what number is bigger. And so I'm going to start in the ones place. And I see that there is a 4 in the ones place on both of these numbers. So that really doesn't help me get very far. So now I'll go to the tenths place, and this one has a 5, and this one has a 0. Now those numbers are different, so all I need to ask myself now is which one is bigger. And the 5 on this one is bigger, meaning that this number 4.5 is much bigger than 4.05. And this makes sense. You can think about it even in money on this problem, that $4.50 would be much greater than $4.05. And 4.5 is halfway between 4 and 5, whereas 4.05 is very close to 4. So then we just draw in our arrow, and we say that that 4.5 is greater than 4.05. Now we're going to go through that same process one more time, or 3 more times actually. And first, let's look at the very first number that's in the ones place. And again, both of them are the same number. In this case, it's a 5. Then we're going to move on to the tenths place and look at what number is in the tenths place. And the one on the left has a 6. The one on the right has a 7. So this means that this number on the right side is greater. So our arrow this time is going to go in the opposite direction. This time it says 5.67 is less than 5.76. All right, now let's look at the next problem. The number in the ones place, they're both a 0, so that does not help us classify or compare these yet. The next numbers are in the tenths place, and they're both zeros as well. So again, so far they're equal. Okay, now let's go to the hundredths place. Each one has a 5 in the hundredths place, so that means that they're equal as well. And finally, one of them stops earlier than the other. So this one has a 1 less 0 after it than this one does. But really, after any number that is a decimal, there is a 0. So what this means is that these two numbers are exactly the same. Okay, they're exactly the same, because if I drop this 0 on this problem, it'd be 0.05. Or if I added a 0 on this one, it would also be 0.050, like the one on the right. So let's look at one more. Okay, so again, in the ones place, they're both zeros. So that doesn't help us. In the tens place, they are a little bit different though. The tens place on this one has a 3, and the tens place on this one has a 0. So we actually don't need to go any farther than that, even though there's numbers after it, to determine which one is bigger, because the one on the left has a larger number than the one on the right, which means that it is going to be bigger. So 0.33 is greater than 0.033. All right, and one more with comparing decimals. Now in this one, we want to figure out what is the correct order for the following numbers. And we want to put them in order of least to greatest. Okay, so we want to put them in order from least to greatest. Now again, I'm just going to start with the ones place on each and go, okay, well, each of them has a 6. All right, so that gets me started on that. And then after that, I'm going to look at the tens place. Well, this one has a 2, this one has a 0, and this one has a 1. And really from there, I just need to find the smallest number, which is the one with the 0 first. And that's going to be our smallest number, 6.02, because 0 is smaller than 1 and 2. So now that that one is gone, I can just cross that one out. It's gone. And say, okay, now let's just look at these two numbers that are left. Well, 6.12 is going to be smaller than 6.21 because the number is 1 first, and then the 2 is greater, so that would come after that. So this would be the order of our numbers. So pretty easy. And most of this should be review. All right, let's go over adding and subtracting decimals now. So Cesar, Chris, and Garrett ran their 800-meter dash. Their times were 1.20, 1.1, and 1.002. What were their combined times? So if we're trying to find the combination of something, we are finding the sum. And when you find the sum, that is adding. So all that we're going to do on this is simply add these numbers up. We're just going to add these numbers up. Okay? And what we will do is we'll just simply make sure first that we have lined up all of the decimals, that we have lined up all of these decimals. And so I can see right here that all of these decimals have been lined up. And then once they're lined up, you can just add zeros after everything else. Zeros after everything else to make it look like it's not so empty. So when we add these numbers up, which is very easy, we just get 3.302, which says that their combined times is going to be 3 minutes and 30 seconds. Now, obviously, we don't want to leave it as 3.302 because that's not what time looks like. It would look like 3 minutes and 30 seconds. All right, let's look at another example. Ping is buying a sandwich for $5.95 and a bottle of juice for $1.75. He is going to pay with a $10 bill. How much money will he get in change? So as you can see, there are a couple steps that you have to follow here. First, we have to figure out how much does everything cost, and then how much will he get in change. So our first step is that we have to find the sum. We have to add these together. And remember, you have to line up the decimals. When you're adding or subtracting, it is very, very important that you line up the decimals. And I'm just going to have this add together for us real quick because I think all of us know how to add decimals. Make sure that you always carry your numbers. And we find out that Ping is going to be spending $7.70 on a sandwich and the bottle of juice. But that wasn't the question. The question said, how much money will he get in change? Okay, so how much will he get in change? When he pays, the person is going to give him some change. How much will that be? How much money will he get back? So now what we need to do is find the difference. And we have to find the difference between the $10 and the $7.70. So we're going to subtract. Now what you see here that's very important, see that again, this is adding and subtracting. We always have to line up the decimals. So you can see that the decimals were lined up. If you don't line up the decimals on adding and subtracting decimals, you're going to get the incorrect answer. Now as you go through this, you're going to have to make sure that you go through the process of, you could do 0 or minus 0. But in this case over here, once you get to 0 minus 7, don't forget that you're still going to have to go through that process of carrying and then adding that 1 there to make it a 10, which is kind of hard because this marker is really big. And when you go through that, you're going to find out that the change is going to be $2.30. $2.30. So Ping will end up receiving $2.30 in change. Now let's go over multiplying and dividing decimals. So Chevron is selling gas for $3.20 a gallon. Emily's car has a gas tank of 20 gallons. How much will it cost to fill up her car with gas? Now in this problem, if you think about it, you're going to have to multiply. And the reason being that obviously that number of what she's going to pay in gas is going to be much greater than $3.20 because the first gallon costs $3.20 and so does the second and the third. So how much does that add up to after 20 gallons? And I mean, you could go and you could add up $3.20 by itself 20 times, but instead of adding multiple times, you can just multiply. So we're just going to multiply $3.20 together. And so when we multiply, it doesn't matter if you line up the decimals anymore. It only matters when you line up the decimals and adding and subtracting. With multiplying and dividing, it's a little bit different, and so the decimals operate differently. So when you're multiplying, it doesn't matter if you line up the decimals as long as you put the decimals in the right place at the end. So first thing, we multiply this first column right here, and everything ends up being 0. You put your placeholder and you multiply that second column, and you get 64.00. Now remember that the decimal will move over 2 places since there are only 2 decimal places. The way I kind of look at it sometimes is I start at the right side and I go, okay, there's 1 decimal and 2 decimal places. So I'm going to move it over 2 decimal places then. But you have to be careful because in some problems you might have decimals down here too. So you have to count how many decimal places there are, and that will tell you how far you will move over. So Emily's going to actually have to pay $64 to put in a full tank of gas. So she will pay $64 for a full tank of gas. And last one. Josiah paid $19.75 for 2.5 pounds of coffee beans. What was the cost of beans per pound? Now we know what the cost was for 2.5 pounds of coffee beans, but the question is asking what's the cost per pound. And whenever they're asking you to find per pound or per dollar or per something, that means you're going to divide so that you can find the unit rate. So that means not when it's 2.5 pounds anymore, but when it's just 1 pound. So when we first set up our division, it's going to look something like this. But we don't want to leave it like that because multiplying by a decimal is not as simple as if we could multiply by a whole number. So instead, what we are going to do is move the decimal over. We're going to move that decimal over. And so when we change that, it ends up looking like this. So this decimal moved over to the right. That way now it's just a solid 25. And this decimal over here, since we moved this one to the right, this one also is going to have to move to the right. And then from here now we can start dividing. So 25 goes into 197 7 times. And 25 times 7 is 175. And when we subtract that, we get 22. Bring down your 5. And 25 times 9 is perfectly 225. So this means that Josiah was paying $7.90 per pound of coffee beans. So pretty simple. All right, now you're going to have a few, I think it's 3 practice problems to work on. They're on the foldable, but you are still going to have to put your answers onto Edpuzzle. So when you solve it, wait until I'm done talking, and then it will give you your answer choices, and you can put those answers into Edpuzzle and see how well you understood this lesson. If you have any questions, please let me know. Thanks.